Hello everyone. Today we will discuss a very important organic term, that is nucleophile. Okay? Nucleophile is a combination of two words. One is nucleus and another is philia. And philia means attraction. So I can say that nucleophile attracts nucleus. Okay? Let's take a little discussion about nucleophile. Okay? Nucleophile is a chemical species that donate an electron pair to form a chemical bond in relation to a reaction. All molecules are ions with a free pair of electrons or at least one pi bond can act as nucleophiles. Okay? And we also know that a Lewis base is any substances such as OH minus ion that can donate a pair of non-bonding electrons. A Lewis base is therefore an electron donor. So we can say that all Lewis bases are nucleophiles. Now we will talk about criteria for being good nucleophile. Okay, so let's start our discussion. At first, we will discuss how nucleophilicity is related to charge. The greater negative charge, the more likely an atom will give up its pair of electrons to form a bond. Thus, you can say that all conjugate base is always a better nucleophile. Okay? And now we will talk about electronegativity. Okay? There is an inverse relation between electronegativity and nucleophilicity. Do you know what is nucleophilicity? Nucleophilicity is the working power of a nucleophile. Okay? And nucleophilicity increases as you go to the left along the periodic table. Okay? Now we will talk about solvent. Okay? There are two type of solvent. One is polar protic solvent and another is polar aprotic solvent. At first we will know what is polar protic solvent. Polar protic solvent, actually any solvent with OH, maybe H2O, maybe ROH, whatever. And in polar protic solvent, nucleophilicity increases as you go down with respect to the periodic table. Then you can find, and in polar aprotic solvent like DMSO, acetone, this order is dramatically reversed, and the most basic nucleophiles are also the most nucleophilic, like okay. We will discuss what is the reason behind it. Let's try to find out. Okay, this is due to hydrogen bonding. Like this, in polar protic solvent, the most basic nucleophiles are surrounded by an entourage of solvent molecules, and the less basic nucleophiles get involved with less hydrogen bonding, therefore more nucleophilic. Okay, now we will discuss about steric bulk. Okay, the bulkier group that are adjacent to a nucleophile atom, the slower reaction will be due to steric hindrance.